First of all, let me just start off by saying thank you for your willingness to watch this on video lecture as opposed to being in the live classroom. My family and I greatly appreciate it. Just a few things before we get started. In class on Tuesday, you should be bringing me the real numbers written assignment. Please be sure to read the directions thoroughly on both sides of that sheet. You should also be through section 1.8 in my math lab. The exam for chapter 1 will be on Thursday during class time. And as always, you will not be allowed to use a calculator on chapter 1's exam. Additionally, on Tuesday, I would love it if you would write the 3 problems that are appearing on your screen. Write these down, and would you, without the use of a calculator, compute the answer to these particular problems? These problems are going to merge the concept of order of operations, fractions, integers, and then positive and negative rules as well. So go ahead and press pause on the video, jot these 3 problems down, solve them, and bring them to class on Tuesday. Okay, let's go ahead and start on section 1.7. In this section, 5 important properties are the focus of this section. The importance of these properties provide the reasoning for why we are allowed to do certain things in mathematics. In chapter 2, we'll be solving algebra equations, and as you know me by now, I will be constantly asking you why certain things we are able to do that. So the 5 properties we're going to talk about today are commutative property, associative, identity, inverse, and distributive. We'll go ahead and start with the commutative property first. My guess is you've used these 5 properties multiple times. You just didn't realize that maybe that's what they were called. The commutative property states that you can change the order of numbers and get the same result. This property only works on 2 of the operations in mathematics, addition and multiplication. It fails for subtraction and division, although oftentimes our brain wants to apply that to those 2 situations. Let me give you some basic examples. This property is stating that 8 plus 5 is going to be the same result as switching the order around, 5 plus 8. 8 plus 5 is 13, 5 plus 8 is 13. Additionally, it works for multiplication. So let's take negative 3 and multiply that by positive 2. This, in turn, will give me the same answer as if I take positive 2 and multiply that by negative 3. We were actually using this property just a smidge in class on Friday. As opposed to saying negative 3 groups of positive 2, it's easier for me to mentally picture 2 groups of negative 3. This property does not, however, work on division. However, sometimes we try to do that. So let's consider 10 divided by 5 and 5 divided by 10. Many times our brain will tell us that these answers are exactly the same. 10 divided by 5 is 2, and 5 divided by 10 is not 2. It is exactly 1/2. So commutative property fails for division, as with subtraction as well. Okay, so those are just some basic examples. Let's talk about places where we actually have used it. Let's say, for example, I want to add the numbers 17 plus 34, subtract 18, add 23, add 16, add 18. Commutative property states that for addition and multiplication, I can change the order and still get the same response. So the first thing I'm going to do is change this subtraction sign to addition, and therefore make this 18 a negative. Order of operations states we must add these numbers from left to right. That might be mentally tougher than changing the order. So for example, I might want to add 17 and 23 together first. I know that 7 and 3 make 10, so 17 and 23 make a nice even decade number. I might also then add 34 and 16 together secondly. Again, 4 and 6 make 10, so 34 and 16 would make a nice decade number. I might also put negative 18 and positive 18 together. As we noted on Friday, that would be considered a 0 pair. Now, most of the time we've done this before, we just have not really taken the time to write that middle step, which is to write them in a different order. Commutative property would state that if I take 17 and add 23, then add 34 and 16, followed by adding a negative 18 and a positive 18, I will get the same result. 17 and 23 makes 40, 34 and 16 makes 50, and negative 18 and positive 18 is 0. Adding this all together, my grand total is 90. Sometimes changing the order makes mental math much easier. My guess is you've also used this property in solving algebra equations. Let's start with an algebra expression. 8x minus 6 plus 3x plus 9. In your past, when you've been taught algebra, I'm guessing you've heard combine like terms. We can say that 8x and 3x are like terms since both of them contain x variables. Commutative property states to change the order of this, I would still get the same answer as long as it's an addition problem. I'm going to go ahead and change the subtraction sign to adding a negative. If I change the order of the problem, 8x plus 3x plus the negative 6 and 9, I can then add these x's together, getting 11x, add these constant terms together, getting positive 3. This is called simplifying an expression by combining like terms. Most of the time, you do not see instructors, or even yourselves most likely, rewriting the problem in a different order, but this property allows us to do that. Okay, property number 2 is the associative property. Associative property says you can change the groupings of the numbers and the result is still the same. Please note that associative property only works on the same two operations, addition and multiplication. Okay, so let's start with a very basic example. Let's say inside parentheses I'm being asked to multiply 5 times 4, and outside of that grouping to multiply that by 2. Let's go ahead and calculate this result. Order of operations says we must do what's inside parentheses first. 5 times 4 is 20, and then 20 times 2 is 40. Associative property says if we change the groupings, we should still end up with the same result. So let me take this same problem. Notice I'm going to write the numbers and the operations in the same order. I'm simply going to change which values are inside the group. This means I have to do 4 times 2 first. This is a quantity of 8. And again, if I multiply 5 times 8, I still end up with 40. This same property works for addition as well. So let's say, for example, we're going to add negative 8 plus 10 plus negative 3. Order of operations, inside parentheses first, this is a 2 plus a negative 3. The end result is negative 1. Let's apply the associative property and change the groupings. So this time, I'm going to be adding 10 and negative 3 first, which would give me a quantity of positive 7. Add that to negative 8, I still end up with a value of negative 1. Please notice this only works if both of these symbols are addition or both of these symbols are multiplication. This property will fail for subtraction and division. Okay, so let's look at a problem where we might actually apply this associative property to make math mentally easier. Say, for example, inside parentheses, I'm being asked to multiply 3/5 times 2/7, and then that quantity multiplied by a negative 7/10. Whoops. So I know that when I multiply fractions, I can reduce before I multiply. So I'm going to apply the associative property to this problem, leave the fractions in the same order, and simply change the groupings. So I'm going to choose to multiply these two fractions together first. Hopefully you're recognizing why I may want to do that. This numerator is 7 and this denominator is 7, therefore I can cancel this 7 with this 7. Just a reminder, the only reason I can cancel that is because this is a multiplication sign, and we know that multiplication and division undo each other. I'm also going to reduce this 2 with this 10. So this 2 goes into itself once, and 2 goes into 10 5 times. So when I multiply these two fractions together, the quantity ends up being negative 1/5. Now I'm going to take this result and multiply that by the 3/5 from before, and the final answer is negative 3/25. Property number 3 is the identity property. Identity states you can perform some mathematical operation, but the result is the same value that you started with. Identity actually works on all 4 operations, which is different than the first 2 properties that we've covered. So let's say, for example, I want to take a number 8 and I want to add something to it and still end up with 8. Logically, that would mean we would have to add 0. It also works for subtract. If I start with 5 and I want to subtract something from it and still end up with the same value of 5. Again, for addition and subtraction, the identity property would be 0. Either add 0 or subtract 0, and you will still have the same result. We actually used the identity property in class on on Friday. So, for example, we had the problem negative 5 take away 2. In class, we started with 5 negatives. And then we ran into the problem where we're supposed to take away 2 positives, but we don't have 2 positives to take away. If you recall from class on Friday, we then added what we called a 0 pair. So this is the identity property. What we're saying is negative 5 plus 0 is still negative 5. This property allows us to add the 2 0 pairs. Once we had the 0 pairs, then we took away the 2 positives, and our final solution was negative 7. We have also used the identity property for multiplication and division countless times in class as well. So let's say this time we want to start with the number 8, only now we want to multiply it by some value and still end up with the number 8. Any guesses on what that value is? 1. Same with division. If I start with the number 8 and I divide it by the value of 1, I still end up with the number 8. So for multiplication and division, the identity property says to multiply by 1 or dividing by 1 gives us the same number that we started with. We have used this to find common denominators and to reduce fractions. So for example, if we had the fraction 8/10 and we wanted to reduce 8/10, identity says as long as we divide this by a value of 1, we will still end up with 8/10. In class, we chose to write our value of 1 a smidge differently. So in this case, the common factor of 8 and 10 is 2. So we chose to write our value of 1 as 2 over 2, therefore reducing this fraction to 4/5. We also can do this with multiplication. So let's say, for example, we want the fraction 2/3 to really have a common denominator of, say, 9. Identity property says that as long as we multiply by a value of 1, we will still end up with 2/3. However, we chose to write the value of 1 differently. So in this case, we're going to write the value of 1 as 3 over 3. 3 divided by 3 is still 1. Identity says if we take a number, multiply it number by 1, we will still end up with the same value. In this case, it will be 6/9 as opposed to 2/3. So we use identity property quite a bit in finding 0 pairs and reducing fractions and finding common denominators. The inverse property is going to probably be the most used property when we start Chapter 2 for solving equations. The inverse property says that we are going to add a value so the result is 0, or multiply by a value so the result becomes 1. This is different from identity in that we now want our result to be a different number as opposed to the number we started with. So say, for example, I start with the number 9, and I really want the number 9 to become 0. So the question is, what am I going to add to the number 9 to get it to equal 0? And in this case, that missing number would be its opposite, so -9. 9 plus its opposite value will always equal 0. Let's say we're going to do the same thing for multiplication. So what am I going to multiply 5 by to get a value of 1? 5 times what will give me a value of 1? Lots of times students want me to put a -5 inside of this box. But a 5 times a -5 will end up being -25, not 1. The trick for multiplication is to find what we call the reciprocal. So if I make 5 be 5 over 1, the reciprocal is that fraction turned upside down. If I take 5 and multiply it by its reciprocal, I will end up with a value of 1. Numerator times numerator, 5 times 1 is 5. 1 times 5 is 5, and we know that 5 divided by 5 really equals 1. This property will become utmost important when the algebra equations we're solving in Chapter 2 contain fractions. So let's say we want to take the fraction 2/3 and get it to have a value of 1. To do this, I'm simply going to multiply by its reciprocal. As I do this, 2 times 3 becomes 6, 3 times 2 becomes 6, and I know that 6 divided by itself gives me a value of 1. The last and final property this video lecture will include is the distributive property. In semesters past, I have found that most students recognize this one because they use it so often. Distributive property states that I'm going to multiply a sum or a difference by a common factor, which will give me the same result as if I distributed that common factor to each term. So let's look at a very basic example. Let's say I want to take two groups of 3 plus 4. Order of operations states that I must do what's inside parentheses first. 3 plus 4 is 7, and if I now take two groups of 7, I end up with 14 total. Distributive states that we can, as opposed to doing what's inside parentheses first, simply distribute this value into both terms first. The key idea here is to remember to do it to both terms. Oftentimes I see students distribute it to the first term, but not the second. So 2 times 3 is 6, and 2 times 4 is 8. So I'm going to rewrite this problem as 6 times 8. 6 from here, 8 from here. Notice that 6 plus 8 still gives me a value of 14. One common mistake I see often with distributive property is in the use of negative signs. So let's assume the problem is 5 minus 3 followed by the quantity of 2 minus 6. Order of operations would tell us to do what's inside the parentheses first, but what I'd like to do on this problem is to apply the distributive property. This 3 should be distributed to both terms with inside this parenthesis. Please notice that if I change this problem to addition, this 3 actually is a -3, and this 6 actually becomes a -6. When I distribute the negative 3 times 2 is negative 6, and negative 3 times a negative 6 becomes a positive 18. And then we still have this 5 here in front. Okay? Really important when you're doing distributive property to watch negative signs very, very carefully. My guess is you've seen distributive property many, many times with variables. Here's one more example of distributive property. And for this particular problem, distributive property is incredibly important. Order of operations says we're supposed to do what's inside parentheses first. However, that is not possible in this case since these are not like terms. I'm then going to apply the distributive property, reminding myself to distribute it to all of the terms within the parentheses. Negative 6 times 3x's is negative 18x's, and negative 6 multiplied by a negative 2 will be a positive 12. Again, watching negative signs very carefully. I would like to show you one really powerful place that mental mathematics can be easier with the use of the distributive property. So let's say, for example, I'm trying to figure out mentally what 4 times 386 is going to be. Now, most of us might go over here to the piece of scratch paper and jot this down and then do some borrowing and some carrying. But let's ponder this idea. What if, instead of writing 386 this way, we choose to write 300 plus 80 plus 6 and apply the concept of the distributive property? 4 times 300 is 1200, and 4 times 80 is 320, and then 4 times 6 is 24. So if I do the multiplication as 3 different values, then I simply need to add these values back together and get 1544. Now, do I think this has to all be written down? No, I simply show you this to make the mental mathematics a smidge easier. Play with the idea, see what you think. As we end this video presentation, I would like to give you 2 more problems to consider and bring to class on Tuesday. Problem number 1. Explain how the commutative property would make this problem easier to mentally compute. Please know that yes, having a final answer to this question is important, but what I'm really looking for is how you can use the commutative property to make it easier. What I might suggest is for you to work it both ways. Start by working this problem left to right as order of operations states, and then see if you can apply the commutative property to make that problem a bit easier mentally. And the fifth and final problem I would like you to consider and bring to class with you on Tuesday is explain how the distributive property would make this problem easier to mentally compute. So again, I know that you can probably use some scratch paper and a pencil to come up with this answer, but what I'm really looking for here is how can we do it in our heads without needing to borrow scratch paper and pencil. Okay, so to wrap this up, once again, by class time on Tuesday, you should have the real numbers written assignment completed and ready to submit. You should be through sections 1.8 through My Math Lab. And the exam for chapter 1 will be in class on Thursday. Please know that I'm still available on Moodle. Should you have any questions, please simply write me a message. Best of luck. See you in class on Tuesday.